Dear students, today we are going to discuss two more problems on numerical integration. Later, we'll discuss about the next topic, Lagrange's interpolation. Here is a problem. We need to evaluate an integral 1 to 4 e to the power 1 by x dx using 4 ordinates. Observe, in the previous problem, we mentioned the number of subintervals and ordinates. So similarly here, he given 4 ordinates. So I already told, if you have a n plus 1 ordinates, we have n subinterval or equal parts. So in the problem given 4 ordinates, therefore the number of subinterval is 3. That is, our n is 3. And observe once again the note, if n is a multiple of 3, we need to apply Simpson's 3/8 rule only. So according to that, in this particular problem, our n is 3, so we need to apply Simpson's 3/8 rule. To apply Simpson's 1/3 rule, n is a multiple of 2. To apply Wedel's rule, n is a multiple of 6. But here n is a multiple of 3, so we can't apply those two cases. We need to apply Simpson's 3/8 rule. Before that, we need to find out the step length and the values of x and y. To find out the step length, as usual, the formula is upper limit minus lower limit divided by the number of subintervals. If we substitute the upper limit as 4, the lower limit is 1, and the number of subinterval is 3, you will get the step length as 1. Now using this step length, we need to find out the values of x, and using that we need to find out the value of y. I told you already, our initial value of x is always our lower limit. Next, x1 is nothing but x0 plus h, and x2 is nothing but x1 plus h, and similarly x3 is x2 plus h. Now here is a given relation y is equal to e to the power 1 by x. To find out y0, replace x by x0, you will get y0 value. To find out y1, replace x by x1, you will get y1 value. Similarly, y2 and y3. I told you already, here n is a multiple of 3, so we need to apply Simpson's 3/8 rule. So consider Simpson's 3/8 rule formula. 3h by 8, the formula is initial value of y and the final value of y. Here the initial value of y is y0 and the final value of y is y3. So first consider that, plus 3 times the number of the terms which are the suffixes which are not a multiple of 3. So here we have, if we consider y0 and y3 here, the remaining terms are y1 and y2. These two are not a multiple of 3. So consider those two here. 3 into y1 plus y2 plus 2 into, here we need to consider the suffix like y3, y6 means the suffixes multiples of 3. But here we don't have any terms which having a suffix multiple of 3. We have y3, but y3 is already here and I already told we are not supposed to repeat any terms. So in this problem, we don't have 2 times of anything. So actually we have plus 2 into no terms exist, so 2 into 0. So that's why here I am not considering that term. So now substitute y0 value, y3 value, y1 and y2. You will get the value of the required definite integral. Now similar to that, we'll discuss one more problem. Evaluate an integral 0 to 1 x by 1 plus x square by taking 9 ordinates. Method is not mentioned here also. So given 9 ordinates, so n plus 1 is 9. So what is n? Is 8. So if we have a 9 ordinates, we have 8 subintervals. That is n is equal to 8. This is not a multiple of 3 and this is not a multiple of 6. This is not a multiple of 6. This is a multiple of 2. So when n is a multiple of 2, we need to apply Simpson's 1/3 rule. We can't apply Simpson's 3/8 and Wedel's rule. Before that, we need to find out the step length. The formula is upper limit minus the lower limit divided by the number of subintervals. So I will get the step length as 1 by 8 because 1 minus 0 by 8 is 1 by 8. Now using this, find out the x values first. I told you x0 is a lower limit, so x0 is 0. And x1, we know that x1 is x0 plus h. So x0 plus h is 1 by 8. Okay. And now x2 is x1 plus h. x1 plus h, that is 1 by 8 plus 1 by 8. 1 by 8 plus 1 by 8 is, we know that 2 by 8. If you simplify that, you will get 1 by 4. So x2 is 1 by 4. Similarly, x3, x4, x5, x6, x7, x8. I will stop here because x8 is 1. That is my upper limit. Now using these values of x in the function x by 1 plus x square, find out y0, y1, y2 until y8. Already told n is equal to 8 is a multiple of 2. So we need to use Simpson's 1/3 rule. So consider Simpson's 1/3 rule. Step length by 3. So step length is 1 by 8 divided by 3. So now here, wait a minute, I will erase that. So now coming to the point, we need to consider Simpson's 1/3 rule. The formula is step length by 3. Initial value of y is y0. Final value of y is y8 plus, this is 1/3 rule. So 4 into odd suffixes y1, y3, y5, y7 plus 2 into even suffixes y2, y4, y6. Observe here, I am not repeating y8 again. Now substitute all the values here. You will get the required value as 0.3466 for a given definite integral x by 1 plus x square by using Simpson's 1/3 rule. So now similar to this, I have given some assignments here. So observe the problem. Evaluate the integral 0 to 6 3x square dividing the interval 0 1 into 6 subinterval. So here n is 6. The problem is n is 6. So if n is 6, this is a multiple of 2, multiple of 3, so multiple of 6. So you can apply any method. I mentioned the answer here. You try, you will get the answer as 216. Similarly, the next problem. Evaluate 0 to 1 1 by 1 plus x dx by taking 7 ordinates. Once again, 7 ordinate means n is equal to 6. So it's a multiple of 2, multiple of 3, multiple of 6. So you can apply any method. You will get the answer as 0.6932. And similar to the problem number 5 and 6, the problem number 7, because n is 6. But when it comes to the problem number 8, find the approximate value of this by using Wedel's rule. Here we mention the method, that is Wedel's rule. So to apply Wedel's rule, n must be a multiple of 6. So you can take n is equal to 6 or 12 or 18 or 24, anything, but prefer n is equal to 6. If the number of subintervals ordinate is not given, prefer the suitable one. For Wedel's rule, n is equal to 6 is the suitable subinterval. So using this, you find out the step length and the value of the definite integral. You will get 1.1873. But one important thing is the function having a trigonometric function. So your calculator should be in a radian mode. Remember this, when the function involves a trigonometric function, your calculator should be in a radian mode to solve the problem number 8. Now, apply Simpson's 3/8 rule for a given integral. So we mentioned 3/8 rule. So to apply 3/8 rule, n must be 3, 6, 9, 12 like this. Prefer n is equal to 3. This is enough. We don't want 6, 9, 12. 3 is a multiple of 3. So prefer n is equal to 3.